So let's talk about the one document that can literally make or break any software project. It's the secret blueprint, the thing that separates those billion-dollar successes from the projects that just, well, fail spectacularly. Let's dive in. I mean, think about it for a second. We've all been there, right? Using an app that's just buggy or slow, or it just flat out doesn't do what you thought it would. So many of these projects, they have millions of dollars and some of the most brilliant minds behind them, but they still end up missing the mark. So why does this keep happening?
The reason is actually pretty simple. They forgot the blueprint. See, building a complex piece of software is a lot like building a house. You wouldn't just show up to a construction site with a pile of bricks and start stacking them, would you? Of course not. You'd start with a really detailed architectural plan. And in the software world, that plan isn't just important. It is everything.
Now, that plan has a name. It's called requirement analysis. This is the very first step in the entire journey. And honestly, it's probably the most important one. This is the stage where you figure out exactly what the customer wants, and you do it before a single line of code gets written. It's all about making sure that everyone, the client, the designers, the developers, are all looking at the same blueprint for the exact same house. Okay, so how do you even start to create this blueprint? Well, you do it by talking to the people who are actually going to live in the house. This whole phase is about gathering every single need, every wish, every desire from the people involved. You kind of have to become part architect, part detective. And you've got a whole toolkit for this job. You can do direct one-on-one interviews, you can send out questionnaires to get broader feedback, and you can even just watch people. Observe them using older systems to see what's frustrating and what actually works. Every one of these methods, from brainstorming sessions to checking out the competition, is about collecting all the puzzle pieces before you even think about putting them together.
Okay, so all these needs you collect, they basically fall into two big buckets. On one side, you have functional requirements. This is what the system has to do. In our house analogy, this is like saying, I need 3 bedrooms and a big kitchen. For a food app, it's show me only the vegetarian restaurants. Simple enough. But then you've got non-functional requirements. This is all about how well it does its job, the quality. This is the good plumbing, the solid electrical wiring. For our app, it's show those results in under 2 seconds. You absolutely need both to have a great product.
So once you've gathered all those functional and non-functional needs, you can't just leave them scattered on a whiteboard. You've got to put them into an official plan, the master blueprint. And in the software world, we call this the Software Requirement Specification, or the SRS. The SRS becomes the single source of truth for the entire project. Seriously, it's this formal, super detailed document that lays out everything the software will do and exactly how it will perform. Think of it like a binding contract between the person who wants the house and the company that's building it. It's all right there in black and white. And having this one document, it just prevents chaos. It gets rid of all those, oh, I thought you meant conversations that can derail a project halfway through. It gives everyone, and I mean everyone, a single unified roadmap to follow. And maybe most importantly, it's also the final exam. When the software is done, you test it against the SRS to see if you actually built what you promised. Now, for most projects, an SRS written in plain English works just fine. But what if you're building software where even a tiny mistake could be catastrophic? I'm talking about the systems that run a bank, or an airplane, or a power grid. For those, you need a language with zero ambiguity. You need the absolute precision of mathematics. You need what are called formal methods. See, the problem with plain English is that it can be, well, fuzzy. What does fast really mean, or user-friendly? When lives or millions of dollars are on the line, you just can't have that kind of vagueness. You have to describe the system's behavior with the unbreakable rules of logic and math.
And this is a perfect example of what I'm talking about. This is called axiomatic specification. Just look at how clean and clear that is. It sets a precondition, a rule that must be true before the action happens. You can only withdraw if your balance is greater than or equal to the amount. Then it sets a postcondition, a rule that must be true after. The new balance absolutely must equal the old balance minus the amount. It's a perfect logical rule with zero room for error.
Another way to do this is with algebraic specification. This basically uses math equations to define how different parts of a system interact. It's kind of like defining the laws of physics for your own little software universe. It's a way to prove, mathematically, that the core pieces of your system will always behave exactly as they're supposed to. But check this out. What if your blueprint was also a working model that you could actually test? That's the wild idea behind an executable specification. You write the spec in a special language that you can actually run like a little simulation. This lets the client click around and test out the system's logic before you've even started coding the real thing. It's pretty cool.
And finally, we have special tools that help us do all this, known as fourth-generation languages, or 4GLs. The easiest example to think of is something like SQL for databases. When you use SQL, you don't tell the computer how to go find the data step by step, you just describe what data you want. These kinds of high-level languages are amazing for specifying exactly what you need, quickly and clearly.
So here's a quick little cheat sheet to pull all that together. You've got axiomatic methods, which use pure logic, algebraic methods, which use equations, executable specs, which are basically simulations, and 4GLs, which are high-level languages to help us say what we want. Each one is just a different tool to get to that perfect clarity in your blueprint, so there's absolutely no chance of a misunderstanding.
All right, so let's bring this all home. Why go through all this trouble? Because a solid plan isn't just about paperwork. It's the foundation for building the right thing, the right way, the very first time. It's really the difference between a house that stands for 100 years and one that collapses in the first big storm.
And the payoff is just massive. You save an incredible amount of time and money. I mean, it can cost 10 times more to fix a bug once it's already in the code than to just fix a typo on paper. You get rid of all that friction between the teams and the client, but most importantly, you make sure that the final product is exactly what the user actually needed all along.
At the end of the day, this isn't just about software. It's about the power of planning things out deliberately, whether you're launching a company or building an app. The rule is the same. A clear plan is your most powerful asset. So, what's the blueprint for your next big project? If you found this useful, make sure to subscribe for more explainers just like this one. Thanks for watching.